Well, hi guys, this is me again, um, and today we are going to talk about some of the nicest functions that you can draw with Desmos. Many of these will be functions that you will have learned in math or you are learning them soon, and they have a weird shape, so it's really important to pay attention what each of these functions is going to do, because sometimes they're gonna be really strange. And we're gonna start with the basic absolute value function. What this absolute value function does is that it takes a number and it turns it to its absolute value, which is positive. So if you do that with a regular x variable, what you get is this. You can see that on the right side over here, you have just the regular y equals x straight line, and then on the left side, apparently you have y equals negative x because the slope is -1. But the whole idea is that what you're getting is a number that is always the positive value of whatever you put into the function. And of course, you can transform this a little bit. For example, you can move it to the right by subtracting some value. So this is the absolute value of x minus 2. You moved it 2 units to the right, and this you can also translate it vertically. See, that's the absolute value of x minus 2 minus 1. So you moved it 2 units to the right, 1 unit down, and you can even make it narrower by multiplying times 3 over here. So you see that the slope on the left side is -3 and the slope on the right side is +3, and so that's the absolute value function for you. Let me change this to projector mode so that the lines look a little thicker. And now let's take a look for another interesting function. Now this one is not available in the usual menu, and oh wait, I need to change the letter, so sorry. um, G of x. So this is not going to be available in the usual menu. You have to go to this functions menu, and over here we might want to go to miscellaneous functions, and there you see this one that says the floor function. And the floor function of x is a very nice, it kind of looks like a staircase like this, and you might wonder, why does it look like that? Well, the reason for this is that the floor function does something very funny. If you have a value between 0 and 1, what it does is that it takes only the integral part of that number. So for example, the floor function of 0.6 is 0, because that's the integral part of that. The floor function of 1.49 is 1, because that's the integral part. And so this function makes one step, 1 unit higher with each unit that you go to the right. Now, just like you have a floor function, you also have what we call a ceiling function. Let me see if we can find it over here. And there it is, the ceiling of x, and you might want to look at it and see that it looks very much like the floor function. But it's not exactly the same. You see, the ceiling function gives you the value that is exactly above. So for example, the ceiling function of 0.6 is 1 because that's the integer that is directly above 0.58 or 0.6. The ceiling function for 1.4 is 2. And so if you look at the two of them together, this is what it looks like. You might think that this is moved 1 unit to the left, but it's actually moved 1 unit up, so that this little segment, for example, from 0, 0 to 1, 0, is actually 1 unit above, from 0, 1 to 1, 1. So that's the ceiling function and the floor function for you. And then we also have some regular curves, like, let's take a look at this. You can also use numbers if you have too many letters. Say f1 of x, we're going to name this little function that will become famous in a while 1 over x. Now, if you make it a little wider, you'll see that there are many interesting points in this thing. For example, if you really go deep down on this, see 1, 1 is a point on this function because 1 over 1 is 1. This one, where you have the x is equal to 2, y is equal to 0.5. And over here, where x is equal to, let me see if I can get this straight. Where x is equal to 0.5, you're going to get that y is equal to 2. And that's called a reciprocal function, 1 over x. Then you also have functions that are not necessarily defined for the whole set of real numbers, like the square root of x. Let's look at that function. You're going to see that you have interesting points here, like 1, 1, because the square root of 1 is 1, but the square root of 4 is 2. And so this function starts out by growing a lot, and then it moves less and less. It becomes less and less steep as you go forward. But the important part is that you don't have any graph to the left of the 0, because of course you don't have any square root of a negative number. Finally, I want to show you this funny function that happens when you take a radius like 16. The square root of 16 is 4 minus x squared. What does that look like? Whoa. And yes, not surprisingly, that looks like half a circle, because this little function over here, the square root of 16 minus x squared, what it tells you is that this function is part of a nice little circle with the equation x squared plus y squared equals to 16, which is a circle of radius 4. So these are some functions that you might want to check out. Some of them are going to be quite useful over the years, so please make sure that you learn them by heart and that you practice them when you get to them in your math class. And that's it for today. Bye bye.